In order to solve an algebraic equation, we first need to simplify the equation as much as possible. A common technique to do this is called collecting like terms. By the end of this lesson, you will be able to identify like terms and merge them together in order to simplify expressions. So what exactly are like terms? Like terms are terms that have the exact same variable with the exact same exponent. So if you look at the boxes on the sheet or on the screen, the first box says these are like terms, and we've got two terms here, 3x squared y and 15x squared y. So if we had to compare them together, what do you notice is the same? Well, the coefficient, or the number at the front of the term, those are different. We've got one that's a 3 and one that's a 15. But if I take a look at the variables, or the letters, and any exponents that are attached to them, both terms have an x squared y. So because they have the exact same variables and the exact same exponents attached to those variables, we can consider these like terms. On the other hand, if we take a look at the second box, these terms are not like terms. So we've got 3x squared y and 3x squared y squared. So the coefficients are the same. They both start with 3, but the coefficients don't really matter. What we care about are the variables, so the letters, and the exponents attached to them. So if we take a look at the x's, so both of these terms have an x squared, okay? But in order for them to be considered like terms, every single letter and every single exponent attached to the letter has to be the same. So both of these terms do have a y component, but the difference is that in this first term, y is raised to an exponent of 1. Remember that if you don't see it, there is still a 1 there. But in the second term, you've got a y squared. So y and y squared, those are not the same. So we cannot consider these to be like terms. They're variables, and any exponents attached to those variables have to be identical. So in our first example, we are asked to identify the like terms in this polynomial. So we've got a very long polynomial expression, lots of terms either being added or subtracted together. So what we want to do is scan across and identify all of the like terms. So I'm going to start with this first term here, which is a 3x cubed. So in order to find like terms that would match with the 3x cubed, I just need to look for any other terms that also have x cubed. So if I scan across, I see I have a 2x cubed, and I've also got a 12x cubed. So everything that I've shaded in yellow, they are considered to be like terms. So I'm just going to write them out so you can see them listed. So we've got 3x cubed, 2x cubed, and 12x cubed. So as you can see, the number in the front, the coefficient, those don't matter. So we've got 3, 2, and 12. Those don't have to be the same. What has to be the same in order for them to be considered to be like terms has to be the variable, so the x, and the exponent attached to the x. So all three terms have x cubed as a part of the term. Okay, let's go back to the polynomial and see if we can identify anything else. So I see here that I have a negative 5x. So I'm going to scan across and see, are there any other terms that also have an x? So as I scan, I see that there is also a 4x. So these are considered to be like terms. So I'm going to list them out here as well. So we've got a negative 5x and a 4x. So how do I know that this is a negative 5x? When you're looking at terms listed like this in a polynomial or one big expression, you just need to pay attention to the sign directly in front of it. So while it might look like a subtraction sign, and technically yes it is, if you're just reading off the number or the term, it actually reads as a negative. So this is not just 5x, it's actually negative 5x. With the 4x, there's a positive in the front of it, or a plus sign. So when you're just reading it off like a normal value, you actually read this as a positive 4x. All right, let's go back to the expression. What's left over? So all that's left over are these plain numbers. So numbers that don't have any letters attached to them. Now, they are considered to be like terms because they're just plain numbers. What they have in common is that they're just plain numbers with no letters attached to them. So they can be listed as their own set of like terms. So we've got 3, -1, and -120. All right, now it's your turn to try. Take a look at this long polynomial listed on the screen. You are going to try to identify all of the different sets of like terms. You can pause the video, try it yourself, and then come back to the video when you're ready to see the answer. All right, so here's the answer or the solution to this question. There are 3 different sets of like terms that you can identify from this polynomial. So our first set are terms that have x squared y attached to them. So we've got 5x squared y, 6x squared y, and 4x squared y. I've colored these ones in yellow. Our next set are terms that have xy attached to them. So we've got -xy, -2xy, and -133xy. These are the ones that I've colored in as green. And our final set are terms that just have an x attached. And so we've got 17.3x and 92x. So now that we know what like terms are, let's take a look at how we can actually use the concept of like terms in order to simplify an algebraic expression. You can simplify a polynomial by adding or subtracting like terms. When adding or subtracting like terms, you're going to keep the variables the same, and you're only going to add or subtract the coefficients. So here's our first practice question. 6x plus 4 plus 8x, take away 3. So our steps are going to be, first we want to rearrange our like terms into groups. Basically we want to collect the like terms, kind of group them or pair them together. And then once we've done that, we can actually go ahead and just add or subtract the like terms using the signs or the operations that were given to us in the original expression. Okay, so what does this all mean? So our first step is to rearrange or collect like terms. So I'm going to scan my equation or my expression, and I'm going to look for things that match up. So what I notice is that I've got a 6x, and do I have any other terms that also have an x? And as I scan, I see that there is an 8x. So these two terms are like terms. So what I'm going to do is on the next line, we put an equal sign, and we're going to group them together. So we're going to say 6x plus 8x. Okay, so that tells me that those two terms need to get added together. So how did I know to put a plus sign? Well, the plus sign is directly attached or in front of the 8x. So they kind of travel together as a pack. So the 8x is a positive, and this is a positive 6x. There's nothing in front of it. There's no sign or operation there. So we just take it to be a positive. All right, let's go back to the expression and see, are there any other like terms that can be collected together? And so what's left over is just a 4 and a -3. These are both plain numbers. They're just plain numbers with no letters attached. So remember, those also could be considered to be like terms with each other. So we are going to group them together. So on the same line, the second line, I'm going to put them in. So I've just recopied them. I've got a plus 4, which came from the original expression, and I've got a -3, which also came from the original expression. All right, our second step is to add or subtract the like terms. So you can only put together things that are like. So that means I can only add together the 6x and the 8x because those are like terms. And I can only put together the 4 and the 3 because those are like terms. So 6x plus 8x is going to be 14x. The only thing you need to add together are the numbers. Do not touch the variable. Do not touch the letter. Okay, so you're just bringing down or recopying the letters as you go, but the numbers are actually going to get the math operations performed on them. So 6 plus 8 is 14. The 6 and the 8 both have x's attached to them, so the 14 should also have an x attached to it as well. We're going to do the same thing with the plain numbers. So this reads as a 4, or if you want to think of it as a positive 4, that's okay. So this reads as 4 take away 3. 4 take away 3 is a positive 1. So I'm going to put in positive or plus 1. So my simplified expression is 14x plus 1. All right, so let's take a look at another couple of examples. So we are asked to simplify the following expressions. So in question A, we've got 3y take away 2y. So are these like terms? Yes, they are. Both terms have a letter y included. So you can just simply subtract these together. So 3y take away 2y is equal to 1y. Now remember in math, you don't necessarily have to write that 1 in the front. So you could also just say y. Question B, 2x plus 3x plus 7. So what are the like terms here? So as I scan across, I see that I have a term 2x, and I also have another term with an x attached, which is the 3x. So those two would be considered like terms. Is the 7 included as a like term? No, it's not. It's just a plain number 7. There is no x attached to it. There is no other letter attached to it. So it is not a like term. So when I put together like terms, really the only thing that I can actually add together is the 2x and the 3x. So 2x plus 3x is 5x. Now there's nothing I can do with the 7. There's nothing I can add to it. There's nothing I can subtract from it. So all I can do with it is just recopy it. So my final answer is going to be 5x plus 7. Okay, let's move on to the next one. It's a little bit more challenging because now we're dealing with terms that have different letters. We've got some x's, we've got some terms with y, and we also have some plain numbers. So remember, you want to collect the like terms. So let's start with 7x and scan across our expression and see, are there any other terms with an x? And I see that I have a positive 2x. So those are like terms. All right, what else do we got? We've got a 2y. I see a 5y as well. Those would be considered like terms. And then I see a plain 11 and a plain 2. So those would be considered like terms. All right, so let's go ahead and on our next line, we're going to put an equal sign and we're going to group together or collect all of our like terms. So let's start with our x's. We've got 7x, and then we also have a positive 2x. Okay, let's move on to our next set. So remember, when we read this, this is going to read as negative 2y. So we're going to put in minus sign or negative sign 2y. The like term with that was a minus or negative 5y. And then we're going to finish off with the plain numbers. So we have a positive 11 and a minus 2. Okay, now we're ready to actually do the math. So let's start with the x's. We have 7x plus 2x. 7x plus 2x is 9x. Okay, then move on to the y's. You've got a negative 2y take away 5y. That would give you a negative 7y. And then you've got 11 take away 2, or a positive 11 take away 2. That would give you a positive 9. So your final answer would be 9x minus 7y plus 9. Now, does the order matter in how you write your final answer or how you state your final answer? And the answer to that is yes, actually it does matter. There is a proper way to state your final simplified expression or equation. And if you take a look at the little note box that's up here in the corner, it tells us that the degree of terms should be in descending order. So your highest degree term is on the left, and then you're going to rank them downwards from highest to lowest. So what does that even mean? Well, if you have terms with exponents, you should be putting them in order from highest to lowest. Okay, so the highest exponent would go first, and then the next highest, and the next highest, and so on. But if you take a look at the question that we just did, there really are no exponents built into the expression. So that rule doesn't really apply here. So what is the rule then if you don't have any exponents? You should keep your terms in alphabetical order. So if we take a look, X comes before Y in the alphabet, and any terms that are just plain numbers with no letters attached to them, they will always come at the very end of your expression or at the very end of your equation. All right, now it's your turn to give it a try. You've got questions D, E, and F to practice. So pause the video, see if you can collect like terms and simplify those three expressions. And when you're ready to see the answer, hit play and I'll go through each one. For question D, your answer should be negative 2x plus 6y. So if you're checking for like terms, the only like terms that appear here are the 3y and the 3y. There is nothing that can be paired together with the negative 2x. Now remember, when you're figuring out what order to put your terms, you want to put them in alphabetical order. So x comes before the y. So I've gone ahead and started my next line, or the next line of my solution, with negative 2x, and then I put in the positive 3y's. Now, if you choose not to do that until the very end, that's okay too. So you could solve everything out, and then once you figure out your answer, you can just make sure that you state them or list them in the correct order. So there's nothing to do with the negative 2x, so that just gets recopied onto the next line. But 3y plus another 3y would give you a positive 6y. For question E, your answer should be negative x plus 6y plus 4. So with collecting like terms here, you've got a couple of different sets. You've got terms that have x's. So you've got a positive 2x and a negative 3x. You have terms that have y's. So you've got a 5y and a positive y. And then you have terms that are just plain numbers. So you have 11 and a negative or minus 7. So when you group them together, you can go ahead and group them right away in alphabetical order. So the x terms should come first. So you've got a 2x and a minus 3x. You've got a 5y and a positive 1y. If you have trouble remembering that there's a 1 there, you can put the 1 into the expression. And then you have your plain numbers, the 11 and the minus 7. So this reads as 2x take away 3x, which is a negative 1x. And again, if you want to include that 1, you can. Then we've got 5y plus 1y, which is a positive 6y. And then you have 11, or a positive 11, take away 7, which is a positive 4. And for example F, we've got a bunch of different variables in this question. And this time you have variables that also have exponents attached to them. So when we're collecting like terms, we've got a couple of sets. We've got a 3x squared that goes together with this minus 2x squared. We have a 4x, which goes together with this 1x. And then we just have this negative 7x cubed kind of by itself. There are no other terms in this expression that have an x cubed. So when you collect your like terms, you might collect them as such. 3x squared, take away 2x squared, plus 4x plus x. Remember, this is also can be read as a 1x. And then you've got this minus 7x cubed just kind of on its own. So when you go ahead and collect like terms, you've got 3x squared, take away 2x squared, which is a 1x squared. You've got 4x plus 1x, which is 5x. And then you just still have that negative 7x cubed, so nothing you can do with it. You're just going to recopy it once more. Now, is this in the correct order? And the answer is no. So how do we put it in the correct order? Remember, the rule was your exponents, if you have terms that have exponents, they need to be in order from highest to lowest degree. So if I take a look at my exponents, I have a term with a squared, a term with a 1 as the exponent. Remember, if you don't see an exponent, there is a 1. And then I have an exponent of 3. So the highest exponent here would be the x cubed. So because it's the highest, it actually should be listed first. So I'm going to put negative 7x cubed. Then following the order, the next highest would be the x squared term, and that's a positive x squared, so we're going to put in positive x squared. And then finally we'll have just the plain 5x, because the exponent of 1 is the lowest between 3, 2, and 1. So your correct final answer in the correct order should be negative 7x cubed plus x squared plus 5x. All right, here's the final example, just kind of like a challenge problem-solving type of question. So we are asked to write an expression in simplest form for the perimeter of the given shape. So in case you've forgotten, to find the perimeter of any shape, you simply need to take the sides and add them together. So we have a trapezoid here, and so to find the perimeter, we just need to add all 4 sides together. But what I do notice is that there isn't anything written here for this left-hand side. But what I do notice is that there are these markings on the left and right-hand sides. So in case you've forgotten, if you see these markings, that means that the sides are the same. So if this side with the marking is listed as 3x plus 5, that means the left-hand side is also going to be 3x plus 5. So in order to find the perimeter, we're going to add all 4 sides together. So I'm going to start my equation with P equals, and in math we use a capital P to represent perimeter. So let's start by adding all the sides together. So I'll start at the top and work my way around. So I have 18x plus 7 plus 3x plus 5 plus 9x minus 2 plus another 3x plus 5. So in order to put this in simplest form, we need to collect like terms. So that means all of the terms with x's are going to be put together, and all of the plain numbers that have no letters attached to them, they are going to be put together. So I've gone ahead and collected my like terms, and as you can see what I've written, I've put in all of the x terms first, and then I put all of the plain numbers together at the very end. So remember, in terms of putting them in the correct order, letters always will come before the plain numbers. So we've got 18x plus 3x plus 9x plus 3x. And if we add all of that together, that's going to give us 33x. If we put together the plain numbers, we've got 7 plus 5, take away 2, plus 5. And that will add up to 15. So I'm going to put in plus 15. So here is our simplified equation for the perimeter of this trapezoid. The second part of the question asks us to determine the perimeter of the shape if we know that x is equal to 5. So I'm going to recopy the equation or the expression that we just came up with. So P equals 33x plus 15. But now it's telling me in this expression, wherever I see the letter x, I'm going to replace it with 5. So I'm going to rewrite this, and I'm going to say 33. But instead of the x, I'm going to put in 5. Remember that anytime we replace a variable with a number, you want to put it inside a bracket. and then we still have the plus 15. So now we can go ahead and actually solve this. 33 multiplied by 5 is 165. And then to that, we are going to add 15. 165 plus 15 is 180. So the perimeter of our shape is 180. Now they didn't actually give us any units. Is it measured in centimeters? Is it measured in meters? Is it measured in inches? They didn't tell us. So in that case, or if you have that situation, what you're going to put at the end is just the word units. We aren't sure what those units are, but we know that there has to be some kind of unit attached to it. So you're just going to put in the word units.